So welcome to the Alabama Aquarium at the Dolphin Island Sea Lab. My name is Mendel Graeber. I'm one of the educators here at the Sea Lab, and today we're going to chat about sand. So yeah, sand is a much more expansive and maybe interesting topic than a lot of people realize. But whenever I teach about sand, I always like to start by asking who can define sand. So I think sand is one of those things that we all feel like we know when we see it, but maybe we're not so firm on our definition of sand. You guys come on in and join us. We got a few seats left. Okay, that's a good start. A eroded material from sedimentary rock. From rock.
Or particle size.
Okay, so any other contributions to a definition of sand? Okay, so somebody mentioned crushed rock. Doesn't necessarily have to be sedimentary, but that's one place where we might say sand originates is from rock. Another would be from living organisms. So crushed coral, there are planktonic organisms that might die and settle and become part of a sand composition. So we would refer to the rock sand or the rocky sand as lithogenous, so that's rocky, or we might call it terrigenous. So, which would be like land-based, and then the sand that comes from crushed living things would be biological origin. But going back to how we define sand, it is defined by its grain size. So it's a granular material, a granular mineral material, natural material, that is of a particular grain size. And that particular grain size might depend a little bit on whom you ask. So, then we get into the question of who defines sand. So if you ask an engineer versus a geologist versus a soil scientist, they might have very slightly different answers for the range. They're very specific. But slightly different ranges for the grain size that is sand. So, in a very loosely speaking, as a definition for sand, then we could get much more specific. But very loosely speaking, it would be this natural granular material that is small enough to be carried by wind, blown around by wind, but not to kind of stay in the wind. So you might have a granular material of a smaller size that can become a part of the aerosol. So you might think of it as kind of dust, but dust is not necessarily mineral. But if we talk about it in terms of mineral, we might say silts and clays are the technical granular materials. They're finer than sand. They can be the same minerals, but ground finer than the grain class that is sand. All right, so if you ask geologists, and I'll kind of focus more on the geological perspective on sand. It is between 0.065 millimeters, which is like a 1/16 of a millimeter, up to 2 millimeters.
So can we ask questions about more?
Sure.
So are you saying that like the topsoil that was blowing around during the dust bowl, that would actually be considered sand?
If it is blown, and so sand can travel in the wind. If you think about, okay, you use the dust bowl as an example, like an agricultural area, or you can think of the beach. A lot of people down here are familiar with kind of getting sandblasted on a windy day at the beach. So sand can be blown around by the wind. It just doesn't get airborne and travel in the wind high and high. So it's not going to travel across the Atlantic Ocean. Like, you can get sediment that blows across the Saharan desert out across the Atlantic.
So during the Dust Bowl, it wasn't blowing far enough to be considered sand?
You may have had some kinds of minerals that were, but that were blowing, but in airborne, but they were not considered sand. Maybe the same minerals, but of a smaller size class. So I got a little, kind of a little activity for you, and I am going to pass around a few physical materials. I have a little group of physical materials. I'm going to ask you guys to kind of inspect them and tell me which of these you think were made. Actually, instead of, I will pass around a couple, one on each side, and then I'll hold up the third one. Okay. So, which were made or derived from sand? All right, so and for these beads, they are not real pearls, but for the sake of this activity, pretend that they are. Okay, and I have some of these that I only have one of instead of three, so we'll kind of make do with this assembly. All right. So one here. You guys just kind of inspect these items. Just kind of classify them in your mind as either derived from sand or made from sand or not.
We've been in Puerto Rico,
It is a what?
a dust cloud.
That's a really loose definition. So the more formal definition is that grain size. And so you may have certain unusual circumstances when you've got like a terrific amount of wind energy, with a hurricane or something. And so then they come airborne. So that definition is kind of, the loose definition for what qualifies as sand. Yeah, so from there you refine that definition to a particular grain.
No, I just said that. I've seen some. That was, all the up there. Right after the.
Yeah, so if you think about some sort of windy event that is not just usual. Okay, so has everybody had a chance to examine the different items? I'll just start with the biggest things I've got. So is this a yay or a nay, sand or not? We're going to get into some philosophical, this will turn into a more philosophical discussion than you might think. So the utility of this activity might become more apparent as we talk. All right, so what is this? This is a styrofoam plate. Is part of its composition?
No.
Okay, so what is styrofoam made of, generally? Petroleum. So a lot of people don't realize that most of our plastics, not all of them, but most of our plastics are made from petroleum. Okay, so I'm going to say not made from cement, but we can come back to it. All right. Aluminum. Sand or not? No? Okay. What is this? Emery board. Made from sand or not?
Probably got no.
Yes. So, they're mostly paper. These, not all emery boards are the same, but these made from paper with sand on the outside. This one, the ones that have red, a lot of these emery boards with the red sand have garnet sand. How about felt? No, this one's a like a plastic felt. Not like a wool felt made from fur. All right, so have you guys had the piece of a clothespin? Wood? Sand or not?
So, yes.
Yes.
So this is glass and made from sand. Can be. No, it largely is. Sandpaper, made from sand, made using sand.
Yes.
Yes. And you may know or notice that you can have sandpaper of different grits, right?
Yes.
Of different sand sizes. This is a piece of an asphalt roofing sheet. Sand. This one has sand in it. Plastic. Okay. Paper. What's paper made of? All right.
Yes, that comes.
A component of the pearl. There's sand. Okay. Sometimes you may have a piece of gritty material that gets in the oyster or clam, producing the pearl. They coat it with their material that they use to make their shell. They coat it, and that's what produces the pearl in nature. Sometimes that little piece may be bigger than what would qualify as sand, but often it would be sand. So possibly, possibly not. Okay, I didn't have one of these in each of your boxes, but I'm gonna pass this around. And so another like rough definition of like if you're out in the field and you can't necessarily, you're not necessarily sorting your grain sizes, which I'm going to show you how you can do in just a minute. But if you can feel it and it feels gritty, generally, you know, you would to separate the sand from the silt process. If it feels gritty, it's generally sand. And if it feels silky, it's silt or clay. So this is a sandstone. So it is a stone that is made of sand that is kind of cemented together into a rock. Okay, What do you think? Yes or no?
No.
What do you think? All right, some people are saying yes, no, maybe.
Is this an example of
Okay, so not is this sand, but was it made of sand? So then we get into maybe questions of a cycle. Okay, so so first of all, this is an oyster shell. How was it made? What makes an oyster shell? An oyster, which is an animal. It is an animal with two shells. And how do they make their shells? So, or another question is, what is this shell made of? Leaving aside whether it's made of sand, or what mineral is it? All right, so calcium carbonate. And so calcium carbonate. So where's it coming from? Where's that calcium carbonate coming from?
sand?
Coming from the water when the oysters use it. So you can think of the bivalve or a snail, a mollusk, mineral parts and the way they produce them, kind of analogous to the way we produce our bones. Okay, so our bodies secrete the minerals that form our bones, right? And where do those minerals come from?
What they eat.
We eat them, so we ingest minerals, our bodies use those minerals to create our bones. So mollusks use calcium that's in the water to produce their shells. So that mineral is dissolved in the water. Okay, so it's dissolved in the water. But so at the point that they're drawing it out of the water to form their shell, it's dissolved. But before it is dissolved in the water, where does it come from? Sand. Could be. Yeah, so you can have this breakdown cycle where it has, before it is in the form of sand, it may be in some other form, like another oyster or a different kind of shell. It breaks down more and more until it's in the form of sand, so it could be classified as sand, continues to break down until it is dissolved, and then another mollusk can reuse that calcium material. Okay, so then we're talking about a mineral cycle here, or a sand cycle. So with that sandstone rock that I passed around, okay, so that was sand. It has been formed into a rock, but of course it can be eroded or ground up and turned back into sand. Okay, so we have a sand cycle here. And sand, and these minerals also move. So they move around physically across the earth in different ways. So they go through a cycle that is different forms, and then they can also go through a cycle, a very long geologic cycle if we're think long term in terms of, say, a mountain building event. We're going to come back to that. Like the uplift of the Appalachians. You've got two continents coming together. It pushes the rock materials of the earth up. Then they begin to weather, and they might, as they are weathering by rivers and streams, they're also being transported. So from the mountains down to the oceans. So we've got a sand cycle, mineral cycle, rock cycle is also part of this equation. We're considering the origins and the fates of sand. Okay, so What is this? Coral. So what do you think? Red sand or not?
Calcium.
Same kind of answer to this as with the oyster. And then I only had one of these, so pass that around, but this is called lava soap. Lava soap. So it has sand in it, and the origin of this sand is volcanic. So another thing to consider when you are thinking about the origins of sand. So is the different processes that contribute to a particular place's sand composition. So some of you have likely been to the beach on Dolphin Island. And so you may have observed the kind of the composition of the sand. I'm going to pass these around if you would like to take one, a magnifier, and help you see the sand. So the sands of Dolphin Island are pretty white. There are some sands in the panhandle of Florida that look even whiter. But our sand is nearly 100% quartz. So if you look at it under magnification, I'm actually going to pass around. You can try looking at this with both a black background and a white background. Sometimes it looks different depending on how the light is striking it or is reflected. So quartz, the silicate minerals are the most abundant in the crust of the earth. So silica sand, quartz sand, is probably the most abundant kind of sand worldwide. Now, if you were talking in a particular region, like in the Florida Keys, they will have a more calcium sand that is ground up, and it's largely ground up shell material. If you're talking worldwide, most sand is a silica sand, a quartz sand. Now, in a lot of places, that sand is mixed. It's not like nearly 100% quartz. It would be a mixture of quartz and other kinds of minerals. And so I'm going to show you some sand samples. I'll show you an example of here it is. You've got we call that like the how homogeneous the sand is. So some of it has a lot of different kinds of minerals in it. Another thing that you can note about these quartz sands, like on the Florida beaches, the North Florida beaches, and Alabama's beach, is that when you have a sand that has such a high composition of quartz, it is an indication that the source of the sand is distant. So the ultimate source of our sand, it came from a long way away. And the reason this gives us this bit of information is because quartz is very resistant to both chemical and mechanical weathering. So calcium, for example, dissolves in water a lot more easily than the silica quartz. So other minerals will be ground down into finer and finer grain sizes. And so as they move, they also get sorted. So you may have those other minerals that kind of they settle out, they get sorted out, while the quartz will continue to, or they get dissolved, while the quartz will continue to move, from the mountains down towards the coast. So if you have a sand that is very high percentage of it is quartz. That's an indication that it was, the origin of that sand was far from from the destination, from where you took a sample of. So with that sorting, I brought this as just kind of an illustration of that sorting process. I don't know that we can actually do this, if it will, be that effective a demonstration under the circumstances. But you guys have probably all maybe taken some sort of loose material of different sizes. So we've got different sizes here. We can think of these as kind of like different grain sizes. And if you ever just gave that a shake, you have probably observed that it will kind of get sorted by size, right? So this is how some of these materials, these granular materials, sort themselves into different sizes, and this is also a product of like the distance that they're moving and being, moved either by water, like in streams and rivers, or ocean currents, or wind. So they get sorted by size. Of course, you can have sands where they don't travel very far. So the volcanic sand would be one example, where the volcanic sands, like in Hawaii, for example, the source of that sand is very nearby. Or the shell sands or coral sands. The source of those sands is nearby, so they don't necessarily get that kind of sorting. This is a biogenous sand, largely coral, and you can see little shells in there too, from Hawaii. So the white page that I'm passing around has kind of a couple questions on it. And one is it sand? Does it fall within the grain size? Does that granular material fall within the grain size that is considered sand? Then, some of the other questions you might ask about sand. And then that sand might lead you to some conclusions about the sand of a place and ultimately the geology of a particular place. And even, we can expand that and even make some interpretations of tectonic movement. So we can actually learn a lot from the sand of a place. So from how homogeneous the sand sample is to how well sorted it is, those give us some clues about the processes that are impacting that sand in its kind of its cycle from source, whatever you might want to peg as the source, because again, this is a cycle. So, ultimately it is moving on the earth and it's taking different forms. But, if we can pinpoint a source, we will say that the sands of Dauphin Island, the Panhandle of Florida, the string of barrier islands from Dauphin Island over to Louisiana, the source was the Appalachian Mountains. This is an ongoing process, but the bulk of the sand that is in the Gulf of Mexico basin eroded from the ancestral Appalachian Mountains. So those mountains have arisen and eroded more than once. So the Appalachian Mountains that we're familiar with today are kind of, we consider them mountains, but they're kind of like gently rolling mountains rather than the higher, sharper, craggy peaks of like the Himalayas. But in their history, they were, their size would have been comparable to the Himalayas, and they have since eroded. If you look at that panel on the wall over there, you see that lighter blue. That is a shallow inland sea that existed during the Cretaceous period, which ended about 75 million years ago, 65 million years ago. And at the time, the Earth was much warmer, so there was less ice on the Earth. Less of the water of Earth was held in ice caps and glaciers. More of it was in the oceans. And so the oceans penetrated the shallow margins of the continents and even this kind of low elevation interior of what is now the United States, all the way up through Canada. And so at the time that the Appalachians were experiencing this higher sea level and the erosion, a lot of that sand was being transported to the Gulf of Mexico basin. So it's thought to have delivered about 20 kilometers of sand to the Gulf of Mexico basin, which actually helped form the basin. So the formation of the Gulf of Mexico there's a lot going on that resulted in the formation. But part of it was this loading of sand from the continent that kind of pushed the basin down. Subsequently, that sand, some of it was moved up onto the shelf to form these islands and peninsulas. So that sand came from the Appalachian Mountains, and it is an ongoing process. So you still have some movement of sand from the lower Appalachians that extend into Alabama down to our coastline. But we're talking the bulk of that sand was eroded long ago when there were rivers that flowed over more of the continent and down to the Gulf. So the orientation, if you think about the orientation of these islands, some of you probably can't see this, but you may be familiar with the map of the Alabama, Mississippi, Louisiana coastline. And you have like this string of islands and peninsulas that run parallel to shore. So one of the processes that is moving this sand and forming these islands and beaches is the longshore current. So that is the current that moves along shore in the northern Gulf of Mexico. It's a wind-driven current, but it's also determined by the margins of the basin. And it flows east to west, carrying sand in kind of a conveyor belt east to west. So this is how we have the formation of these islands and peninsulas in this long, narrow, perpendicular form along the coast of the northern Gulf of Mexico. All right, so this is a sand sorter, and so this is what a geologist might use to sort the granular material, not just sand. But we've got gravel, and so some of the larger materials that would not qualify as sand. Fine gravel, so the sand would pass through this. You would stack them with the largest mesh to the smallest. Fine gravel. This one is coarse sand. So the fine sand would pass through that. So you're kind of sorting your sample. And you've got fine sand, and then the finer material, the silts and the clays, would pass through. So in this system, we're not sorting the clays from the silts. So, do you guys have any questions? So it's a lot of information about sand and a lot that we can learn from sand. So, any questions so far? So I have some sand from Dauphin Island. If you are interested in taking a closer look at some of the sand from Dauphin Island. And also, I have an activity that I do even with very young kids. And I always think that it is really amazing with a very little bit of a guided observation. They are able to sort out sand that looks, sand samples. If I give them a number of sand samples from different areas, well, no, I mean, like, some of these look very obviously different. Okay, so we've got the ones that have a lot of dark minerals in them. It looks very different than, say, Dauphin Island sand, or one that has a lot of shells or broken down coral. Looks pretty different. If you can use a hand lens, looks pretty different than our silica sands. But even if I select a few that have a kind of a similar, it looks superficially pretty similar to Dauphin Island sands, if I ask them to kind of match sand samples, a known sand sample to one that's not known, they're able to do this using some questions about the composition and the sorting. And so if you would like to take a closer look at this, it kind of, requires a look at several of the samples at the same time. You are welcome to stay, and we'll pull that out after I say goodbye to the folks who may be watching the stream. So if there are any questions, feel free to ask. And I will say thanks for joining us. And we will close that out.